Hello. Welcome to Coder Radio. It's Mike as usual. Today I have Shawn Hymel, who does tons of IoT-focused, embedded development-focused, very Linuxy stuff here, courses and videos. He's worked a bunch of places. He's really been in this space for a long time. If you follow him on LinkedIn or his YouTube channels, name a project with an embedded device or, like a Raspberry Pi, or he likes Arduino quite a lot. And he's probably got a tutorial on it. We go pretty deeper than usual, I'd say, but there's definitely going to have to be a follow-up on kind of, where this embedded stuff is going, what effects the whole, AI hype train's having on that. I think this is going to be something that you folks find pretty interesting. So, yeah, enjoy. But before that, of course, housekeeping. Do get in that Discord, link in the show notes. And as always, it's brought to you by the Mad Botter. And for now, we're doing a promo. Use the word coder or just email me and mention coder. It's 15% off for a limited time, the entire platform. So that's Alice. That's our data platform. You go to the madbotter.com/data. The whole pitch is your data, your hardware, if you want. End-to-end data. So that's your shop floor, your job site, all the way to the dashboard. Everything is pre-done. It can, of course, be customized if you want. Custom data lake, again, based on our, some open source and some of our proprietary stuff, but hosted on your hardware. No more crazy Snowflake fees. No more crazy, those Google App Engine fees will kill you after a while, right? Or Azure fees, I think, would be more likely for you guys. So give it a look. Again, it's your data end to end on your hardware, and that code is coder. All right, here's Shawn. All right, here he is, the Shawn Hymel, instructor extraordinaire for all things IoT, Edge AI, machine learning. And what the hell does Edge AI mean, Shawn?
Oh, that's a great question, Mike. First of all, thanks for having me on the show.
Good to
and
have you
Edge
back.
AI is kind of thanks. Edge AI is basically the new buzzword around running AI algorithms on any sort of edge device. That can mean your personal computer, your smartphone, a wristwatch, what have you, but it also includes things like IoT devices. So what we were calling TinyML, I don't know, what was that, 4 years ago, is now being assumed. Yeah, it was like mid-COVID. This TinyML thing is now being assumed into this whole Edge AI umbrella where we're running AI algorithms on these smaller devices. And I'm particularly interested in the microcontroller side because that's the embedded side that I really enjoy.
Interesting. So when we say IoT, we're talking about things like my beloved Beagle Bones, I'm assuming?
Indeed. IoT, that's another giant umbrella term. Yep. Internet of Things. That is pretty much anything connected to the internet that's not a personal computer, smartphone. Wristwatches, smartwatches kind of fall into that category. But I heard somebody give it a description of, I believe my buddy Nick Poole described it as anything that is connected to the internet that does not have a user interface is considered an IoT device. There's many definitions, but I really like that one.
That is good though, but then it gets weird, right? So your like smart fridge is all of a sudden not IoT if it has a touchscreen, but if it doesn't,
yeah, exactly. So it's kind of a weird definition. So yeah, I would consider a smart fridge IoT. So maybe something that's not running a full browser or a full operating system, like a general purpose operating system. I'm not including RTOSs in here.
Right. Like robotics OS, stuff like that is I think that's a whole different category. Generally. But
you can still have Linux, right? You can still have embedded Linux devices that connect to the internet.
But I was just going to say, my Beagle Bones that I deploy for my work are all running Debian. So I don't know. Yep. I mean, there's no desktop environment, obviously, but it's
so maybe that's the differentiator.
Just having a DE.
Yeah. Some sort of desktop environment. Maybe you can have an interface. Maybe it can be an operating system. But like there's a weird kind of gray boundary between what makes something IoT versus an end user device.
Yeah, it's so tough now. And with we could categorize things all day. So when you say Edge AI, are you running things like TinyML on, let's say, an Arduino or something like that, or is that me grossly misunderstanding?
No, that's exactly what's going on. The original Arduino Uno R3s, those were super low power, 16-bit devices.
Oh, yeah.
They're not, you can run, something like linear regression or k-means clustering. Technically, those are ML algorithms. They're just kind of very simplified version. So you could do some basic anomaly detection with an UNO R3 with k-means clustering, and it's going to be fine. But we're talking about usually neural networks, something a little heftier, requiring more memory, more processing speed. And that's where we get into these ARM class devices, these, Cortex M3s, M4s at the very minimum to be able to do some simple neural network stuff. And I think since we've talked last, I spent a couple of years working as DevRel for Edge Impulse, trying to bring this to the masses, trying to get this stuff to run on Arduinos, teaching it. I was going around to schools, I was going around to events, running workshops, showing people how you can collect data. You generally train the machine learning model on the cloud because the training is actually the really tough part. And then, it's very heavy. And then when you have the model, you can just deploy that model to a smaller device. Now, this is just a collection of matrix operations for things like basic neural networks. And you would deploy these to Arduino, like the M3, M4 class devices. And you can do the basic magic wand demo. Can you classify gestures? We were doing keyword spotting and a little bit of vision processing at the time where we could classify, hey, was there a person in the image or not? That kind of thing.
Got it. Very cool. So just maybe a step back for some of our listeners who aren't super familiar with the embedded / IoT / who knows where the boundary is world. We say size or heavy or words like that. We don't mean necessarily, how big in megabytes is your program. It means how much processing intensity, how much memory does it use? Particularly when you get into the ML stuff, you generally don't have GPUs, right? You're running something that looks like a hockey puck.
A hockey puck. Yeah. I mean, it's all CPU bound operations. Right. And so, you have to optimize for that. And there's libraries to help you do it. You get into things like some of the M4 devices, you get SIMD. So you can speed up some of it. And you also get some benefit from DSP operations. So if you've got DSP acceleration, you can take advantage of things like your multiply and accumulate operations in order to speed that up. But it's still not to the same degree that a GPU would give you, just because that is so heavily optimized for massive SIMD, these huge 1,000 by 1,000 matrices being multiplied together. It's just, orders of magnitude better and more efficient to be able to do that.
Your RTX whatever can brute force the calculations, which is why training on those machines. And then I use the word cheating to explain it to non-technical clients, but I could imagine you would want to choke me for that. But kind of, pre-baking little cheats in to the IoT device to be like, oh, don't worry, you just know this because I say so, right?
I mean, kind of, you're not wrong, right? Where you can optimize things away. If you know there's a static, variable or a static constant somewhere, you just set that, right? You're just, if that's a cheat, so be it. That's the name of the game when it comes to embedded development a lot of times. It's where can I make those little cheats? No, I think cheat's fine. That's a good word.
Okay, because I've gotten crap for it before because it's... But you didn't really make the inference. Yeah, but we just practically know where we're deploying this and what it is. So why do we have to infer that every time?
Well, actually, you make an incredibly good point about understanding your environment, right? You say where we're going to deploy this. And that makes a huge difference because what we're not trying to do for a lot of these TinyML or edge AI models is create this all-knowing model that works in every situation, right? We're not trying to create something like ChatGPT. That's just bonkers to run on something like a microcontroller. There are efforts to run LLMs on microcontrollers, not talking about those. But I mean, I want to identify if there's a person in the picture. And you can sit there all day and try to train this model. The reality is your model is going to be very big if you're trying to get it to work for every use case. So what a lot of times you do are the cheats, like you're referring to, is understanding your deployment environment. Hey, is this outside or is this inside? Do I have controlled lighting? Am I just looking at a conveyor belt? If I'm just looking at a conveyor belt and counting parts, I can make a much smaller, more efficient model because I can assume the background is black all the time and I have controlled lighting. So the more complex and robust you make the model, the more RAM, the more processing power, the heavier the model becomes and the more processing power you need on your device. So you want to make these cheats, you want to make these assumptions so you can train a much smaller model that works for your particular use case in order for it to work and run on low power, smaller device, which means cheaper, quantities of scale, blah, 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 blah. All those good things go into it.
I couldn't agree more. So you have a bunch of courses on this stuff. Where should someone start?
So I have a couple of courses on Coursera. That's Intro to TinyML or what did I call it? Embedded machine learning. Those are found on Coursera. So there's 2 of them under the Edge Impulse name. There's a third one that's been added, something I did as a very, very high level, more like if you're a manager, you just want to learn about this stuff. It's just Intro to Edge AI. And it goes through, a lot of the terms and definitions that we're talking about here. What is AI? What is machine learning? What is TinyML? What is Edge AI? We just go through those. And then for the other 2 courses, the first one we dive into how do you actually train a model? And we're using Edge Impulse for this. You collect data. We do, the basic magic wand demo. We do some basic keyword spotting. Yeah, I walk you through all of this. And we deploy it to an Arduino Nano 33 BLE. I think it's the 33 BLE Sense. I think that's the board we were using. It's been a while. It's been a couple of years since I've released that course. And then the next course, we go into some vision processing where we do basic things like, hey, let's talk about convolution. How do we create a convolutional neural network? And then we use it to do image classification. And I barely talk about object detection in that, where we identify what an object is in the image, and you can identify multiple objects. So now you're getting into things like, oh, now I spot cars on the road or people on the road. So you can start developing for things like self-driving cars. So object detection is incredibly important. It's just usually very, very heavy models that struggle to run on microcontrollers. So those are the 2 courses I recommend to get started with. If you really want to dive into the math behind machine learning, Andrew Ng's courses on Coursera, also fantastic. And Professor Reddy on edX has a series of TinyML courses that they dive very deep into, and you're diving into the libraries and not hand-waving the training like I do with Edge Impulse.
We love hand-waving here. What are you talking
about? I know. Well, it's,
the
exactly. Professor Reddy described it as, my course, Shawn's course is the appetizer, and his course was like the full meal if you really want to dive into the math behind it. And both do well. It's just, if you just want to get your toes wet, try out my course and see if you enjoy that kind of thing.
Right. No, it makes sense. So okay. Having a little fun here then. I know you love your Arduinos, and I have nothing against them. I've used them, I've deployed them, not a problem. I'm right now, mostly because I had a cute logo and I tried them out years ago, in love with the Beagle Bones. That's kind of sad. There's also a real practical reason. I'm doing some stuff in environments that are awfully humid and kind of rough. So they actually make, I don't know if you know this, but through some weird subsidiary, it says Texas Instruments on the back, but there's all kinds of corporate shell game crap going on because you buy it from a different vendor. They make a pre-ruggedized one that can actually handle some level of humidity pretty well. But that's obviously like you have to order that. It's a pain in the butt. You're not buying that on Amazon, right? What is a good board for folks to get started with? Is it still the Pi, or is that kind of too high level these days?
It depends on what you're trying to do, right? So, if you want to dive into embedded Linux, I still think the Pi is a great getting started device. The Beagle Bones are fantastic in that, you can buy the ruggedized versions. You can get, I am forgetting the name of the coprocessor that's on that allows you to do very tight pin timing, which makes the Beagle Bone. I want to say it's like the GRU, and I can't remember the name of it right now.
Yeah, they have a bunch of models now, but they're not really targeting consumers. I mean,
So those Beagle Bones are amazing for the next level beyond Pi of I want to make slightly more industrial stuff. I want to connect pins. I want to control pin timing. I think they're a little more ruggedized, but for consumer just wanting to like tinker around with embedded Linux, it's hard to beat a Pi. Even if you can find cheaper ones out there or more ruggedized versions,
right.
The experience of the Pi of getting up to a Debian environment using their Raspbian build or Raspberry or Pi OS, I believe they call it now. It's hard to beat that. It's hard to beat their experience. It's just so well supported. You're probably not going to be fighting with Linux drivers, at least for a while until you dig
I don't
deep.
think you will at all, really. Yeah. I mean,
yeah.
There's a whole ecosystem of, you slap on a touchscreen. The Pi has the drivers for it, right? Slap on pH sensors if you're a nut like me and try to do a hydroponic system in your house.
That sounds awesome.
But you would just buy it. It comes to you, and there's no like, oh, I have to reflash a different version of Raspbian or Pi OS, whatever they call it now. It's, it knows what this is and it just pipes it through.
I mean, you still have to flash. Like, it doesn't come with flash memory.
No. I mean, after you've initially when you've already flashed, I'm saying vanilla Raspbian, right? You don't need to
You don't need to like
update update your drivers or do anything.
It comes with pretty much everything you need, and it's all aptitude based. You can apt-get whatever you want because it's based on Debian. It's super easy to get started.
Okay, so we're still loving the pies for the people here.
Yeah, generally, I still think it's the easiest way to get started. It's just the support is so good; it's hard to beat that.
That's true. You could go on YouTube and find who knows how many
everything.
Yeah.
For microcontrollers, Arduino stuff's still pretty easy. I work with a local college here for a lot of their getting started, freshman level, let's tinker with microcontrollers. They're still using some variant of the Arduino R3 because it's dead simple. Most of the time these students are just wanting to like blink some lights, control some servos, read some sensors, and it's hard to beat that. So even though Arduino keeps pushing out these, newer, more powerful boards, it's hard to beat that R3, that interface, all the libraries still work. And that's just a great way just to blink some stuff, get started understanding what it's like to work with a microcontroller.
Yeah, it makes sense. I mean, these skills are fairly transferable, right? I mean, if you can start with the R3 and just get the basics of how to, integrate a sensor, just get it running really, you can probably move on to another platform relatively easily. Assuming it's not like, I don't know, we didn't even talk about RISC, and I don't think we should because that's just so different.
Like a RISC-V, the RISC-V process.
Yeah, that's just like a whole another galaxy.
I mean, the one I tinkered with a while ago, it's basically same kind of thing. I think it had very limited Arduino support. You're going to write in C or C++, and as long as the compiler supports what you're trying to do, kind of a similar experience. It's just questionable whether your libraries are going to work with it. But that's kind of the same thing for any of these newer boards that Arduino's putting out anyway. I had issues with some of their newer stuff where the libraries just straight didn't compile for it. It just wasn't either tested or developed, or the pins are different, and whoever made the libraries generally targeted the Uno R3 and didn't target these later boards. It's just the nature of how popular the R3 was for, what was that, 10 years, 15 years.
Oh, that was the default. If you took a class or even did like an online, web class, it usually was the Arduino R3.
Exactly.
That was the default. I'm surprised they don't just keep making it. I mean, they probably sell them.
Yeah, they might. You'll have to forgive me.
Who knows? Maybe they
looked
do.
into it. Yeah. I mean, you can find all sorts of knockoffs on Amazon now for super cheap, and that's honestly what the school is using. They just go to Amazon and buy these like Elegoo kits for $15 per student, and they've got essentially an R3
because that's an open system and anybody can clone it.
Yep, as long as you don't put the Arduino logo on it, you're good.
You're good to go. Yeah, that's fair enough. So, what are good? Let's say you've got your Arduino, you've done a couple projects, you've watched your course. What is like? I'm trying to think of a way to phrase this. Let's say you're a hobbyist, right? Your day job is you're an enterprise developer, but you want to build something at home. I don't know. A lot of people write in about coffee. I don't know, some kind of coffee alarm or something, right? Little coffee gadget.
Okay, I got the perfect coffee gadget.
I somehow knew you would. That's why I went there, because I couldn't think of anything. Go for it.
I didn't build it. I think it was Chris Gamble who put this out, who put it on social media, and it was, he was posting about somebody's video, and I apologize if it wasn't Chris, but I think it is. And are you familiar with mocha pots?
I am not.
Oh, it is my new way to make coffee because I don't want a $700 espresso machine, but I love the taste of espresso. So for like $40 on Amazon, you can go buy a mocha pot. And this is actually like an old invention made in like, my goodness, 1800s or something. This is actually before espressos became a thing. And it's basically this little like pot thing. I'm sure you've seen them. They look like these little like octagonal, like hourglass looking pots. I'm sure you've seen them.
Oh, I have seen those.
Yes, that's a mocha pot.
That's what that is?
Yes. So you put a little water in the bottom, that little bottom hourglass part. Yep. You put it on the stove. It boils through a basket, like essentially a little filter where you put your coffee grounds in. You usually don't want to pack them too tightly like you would for a full espresso machine. And so it puts steam through the coffee beans, and it comes out a little spigot in the top, and the top part of the hourglass fills up with essentially what is espresso. Now, true espresso aficionados will tell you it's not made with the same PSI. It's not made with the same pressure, so it's not a true espresso, whatever. We can argue that all day. I call it a poor man's espresso, and it tastes darn close when you make it right. It is very sensitive to the type of bean you use. It's very sensitive to like how much you pack it and how long you leave it on the stove. So you have to dial in your variables when it comes to that. And for me personally, I've got this little mocha pot. I use the San Francisco Bay coffee grinds. It's, not super expensive. They're not really that cheap, but they taste great. And, I do a light pack, brilliant. Every day I have my little like cortado, tastes amazing. So this video that was posted, somebody created this DIY mocha pot timer with a feedback loop. It was like PID controlled, and it was like a little hot plate, and they had like a sensor. I can't remember where the sensor was, like if it was in where the coffee was or on the pot itself, and it fed back into a controller, and it would control the temperature and time for your mocha pot to boil the water and create your coffee. So you ideally got a perfect, or at least you could replicate easy how you made your coffee each time using this full controller. I'm like, man, that is like next level coffee making. You probably spend $200 on parts and 5 hours putting this thing together in order to like use your $40 mocha pot, right? Which
worth it just for the honor, right?
I've been tempted to do it just because it's ridiculous and I love it. But that is the coffee pot. Now, forgive me, I don't remember which controller is in there, but you could probably get away with an Uno R3 because it's a real simple PID loop with like a temperature sensor and a timer and, controlling a relay to turn your hot plate on and off. Like that's kind of it.
That sounds amazing.
Yeah. But for next level stuff, you're talking about your hydroponic farm. If you want to make IoT, you want to make IoT devices, it is still so hard to beat the ESP32. There's Arduino support. The Arduino library for it is fantastic. It generally just works on the internet, and it's powerful enough to support things like HTTPS and all your security needs. And they're cheap. You can find boards of every configuration, and they're cheap. So that is my go-to of, I need some sort of connectivity, either Bluetooth or Wi-Fi. I grab an ESP32.
Makes sense, yeah. Especially if you're doing something local, that Bluetooth can go a long way.
Yeah. Now, I generally don't like mess around with Bluetooth because it's such a pain in the butt.
You don't like the instability of it disconnecting all the time?
Oh, that's like the least of my worries. I mean, just setting up like the characteristics and whatever for something like BLE, wraps my head in circles trying to do it. I've done it a couple of times, and I'm not a Bluetooth developer, but I'm sure, Bluetooth developers are like, oh, it's easy once you get the hang of it.
I hate Bluetooth. It's just
right.
So, I am not a Bluetooth expert. Every time I've tried to use BLE, it's like, so this is probably going to we have to have lots of contingencies for intermittent failure.
Yes. And yeah, BLE is such a pain.
Well, Shawn, it's been great having you on. We've learned a lot. Let's put links to everything in the show notes. I imagine your favorite tool is going to be your mocha pot.
Favorite tool is mocha pot. Right now, it is keeping me caffeinated. So
you know what? It's the only thing that keeps you going. Same here. I'm a little ashamed because I do have one of those fancy $500 espresso machines.
Oh, no, they're great. I will say, like, they produce espresso better than a mocha pot. I'm just cheap and don't want to put something on my counter, so mocha pot it is. And maybe one day I'll get one because I'm not.
I was seduced by an Amazon Black Friday, and it's like the Italian brand, and it's all. But let me tell you something. This thing is so much maintenance. I kind of wish I had just known about the mocha pot because this thing is
because it's like clean it and you're done. It's like the stupidest simple machine ever. It just produces steam.
This thing is like it's like a Ferrari. I'm like it's like nice you own it.
But Italian.
It's Italian. It's just like I'm sorry the water was not perfectly temperatured.
I break.
Therefore, your coffee sucks. Or espresso sucks. Yeah.
Oh, but it's brilliant when it works.
Oh, but the once a month I do it right. Let me tell you that tiny little cup of espresso is amazing.
So good.
Once every 30 days, whether I like it or not.
Yeah.
All right, Shawn. Well, we'll have links to everything in the show notes, and hope to talk to you soon.
Yeah. Can I make one more shout out before we go? The thing we didn't get to even talk about, maybe for next time, is the idea of NPUs, where they are their acceleration on these microcontrollers. And I'm just finished up a series for Renaissance, so hopefully in the next month or so, there will be a full 12-part series of using an NPU where we build up to doing full object detection. So like identify person in the frame and how many people. It crushes through these machine learning models. Like this machine learning model we use, it crushes through it in like 3 milliseconds. It's insanely fast.
Well, you know what? That sounds like synergy to me. So let's have you on right when that releases.
Oh, that sounds like a great idea. I'll let you know.
All right. Sounds good, man. Talk to you in about a month.
Yeah. Thanks, Mike. Have a good one.
You too.